So when we come to think about interdisciplinarity in higher education, it's a very contested term. So there's a variety of definitions. Our particular take here at IATL is that there's three levels to this, and the first is multidisciplinarity, which is, for example, what you might get in a joint degree. So you do modules from one department and you do modules from another one. The second, more developed stage of that is interdisciplinarity. So you might have a situation where two departments are feeding into a single module at their particular departmental interests. And that's a very useful and interesting model of collaboration. I think the stage that we're seeking to reach always is that of transdisciplinarity. So what happens under those conditions is it ceases to be a disciplinary issue and it becomes a problem-based issue. So instead of thinking about it from a chemistry perspective or an English perspective, you think about what the problem is. So the problem is climate change, so then that comes first, the disciplines come second. In that way, you're encouraging students to be able to engage in a way that's actually much more relevant to what they're going to encounter in the real world. The real world does not consist of disciplines, it consists of problems and complex difficulties that they're going to need to address in their working lives. This, for me, is the value of interdisciplinary study in higher education. If we're not doing this and we're not doing it more, then we're going to be failing our students in the future. And of course there's employability issues connected to that. If you talk to many employers, and I've been talking to some in engineering recently, they're not so much interested in having trained engineers come to work for them. They're interested in having problem solvers, they're interested in people with critical thinking skills, people who can collaborate, people who can generate their own knowledge. And for me, interdisciplinarity is the key to that process. We were asked by maths, for example, to do a workshop on abstraction, which is an important concept. These kind of very complex ideas can be applied across whole faculties, actually. The business of the abstract is as interesting to an art historian as it is to a mathematician, as it is to a chemist or a physicist. So in terms of content, this is where we go. We go to issues, we go to problems. Another example of that would be working with chemists in a theatrical space, where the students have to embody the idea of elements that they're allocated. What does it look like to embody the element of mercury, for example, and how better might you understand the behaviour of that element by behaving like it? It's easy to think of the pedagogical approaches as superficial, but in fact what they're doing is offering a more penetrating understanding of a discipline. It's a misconception to imagine that the body in academic life is simply a carrier for the brain. We're much more holistic than that as human beings, even if we think we are. We know things in our bodies in ways that we know things intellectually. In fact, there's no difference. So for me, interdisciplinarity also gets to that really age-old Cartesian problem of mind and body.